college classes, okay.
My friend is also in the college classes.
Alright guys, I feel like each group has gotten to the point where every member of their group is like, I have no idea. So let's all kind of go back where you want to be. We're going to go over this together. I'm going to see if anybody can help me out do some of these. And we'll do the ones that maybe none of us were able to kind of figure out. I think that first one, I saw most people had stuff filled in. So let's see how that went, this first guy. Somebody tell me, what's one way you got this to become a decimal? Anybody?
Multiply it by 2.
Yeah.
I like it. So all decimals are fractions that fit into our base 10 number system. I have no idea why we have base 10. No. So obviously, the theory is because we have 10 fingers. So if we had 8 fingers, we'd have a base 8 number system. And the highest digit our number system would go up to would be 7. So that would be weird. So base 10, if I just make this into some tenths, so multiply it by 2 on the top and bottom, I get 6 tenths. And then that becomes a decimal immediately, right? And of course, real quick, this is the hundreds place. Hundreds, right? Tens. So every time I take a step, I divide by 10. Just to make sure, because I've had people in calculus classes like, what place is this? So if you divide by 10, if this is the ones place, divide by 10, that must be the tens place. And that must be the 100ths place. You just keep dividing by 10. So 6 tenths, I would write it as 0.6. So all a decimal is a way to write a fraction that's some amount of tenths. Over 10, over 100, over 1,000. Okay. And then, what's the quick way to go from decimal to percent? Multiply by 100. Right, because what's percent mean? Per 100. I love it. In fact, the funny thing about the symbol percent, it looks like 100 that we just sort of put the thing in the middle, right? So percent literally means per 100. So if this is 6 out of 10, you could make it 60 over 100 and see a 60%, for example. You could do it that way. This is multiply by 10 on top bottom, it's 60%, 60 per 100. Or just move the decimal once twice, so you get 60%. So quick way to kind of remember that. And again, percent means divide by 100. That's why the percent number will always be bigger than the decimal number, because the percent number hasn't been divided yet. Does that make sense? What was I about to say? Or something else I was going to say. That's fine. So what about this guy? Oh, here it is. That's what I was going to say. If I put the letters for decimal and percent in alphabetical order, if I want to go from decimal to percent, I move the decimal place that way. If I want to go from percent to decimal, I move it that way. Is that cool? And of course, you just got to remember it's twice, because it's based on 100. So what about this guy? How does this become a decimal?
Divide by 100.
You divide by 100, just move that back twice. 0.427. And then what place is that in for the fraction? Tens, hundreds, thousandths. 427 thousandths. All right, so we can all sound like we got a lift when we talk about that. All right. And of course, this works the same way. This again is going to be tenths, hundreds, thousandths. The funny thing is, you can reduce this. On this kind of problem, I actually wouldn't want to see it reduced, because if you use your calculator to get a fraction, it'll give you a reduced form. It doesn't matter. In reality, we're going to mostly be using decimals in here anyway, but we have to know how to do fractions, decimals, percentages. What would that be as a percent?
6.4.
Yeah, you got to move this sucker twice over, once, twice, 6.4%. I love it. Okay, yes. How you guys doing? Is this first problem seemed to be most everybody had at least some answers down. This one is a little weird. People see this guy and they're like, oh, he's already so tiny. But the percent to decimal tells me I've got to move that decimal back twice, right? So then I get a couple more zeros. So I get that. So I got to move it back once, twice. And what is this going to be? Tenths, hundreds, thousandths,
10,000.
10,000th. Okay, the gas. And then finally, the number 1 would be 100%. 1 would be a whole thing. 1 pi is 100% of a pi. So 1.12 should be more than freaking 100%, right? It's like a pi and 12/100ths of a pi, right? So to make that into a fraction, you can do it 2 different ways. You can have an improper fraction, or you can have a what? Mixed number. So all a mixed number means is you have a whole part, 1, and then the fractional part. And I kind of gave this away a minute ago. What would that be as a fraction, the 0.12? 1200. So you can write it as 1 and 12/100ths. So this could be 1 and 12/100ths. Or it could just be 112 over 100. Isn't this in the hundredths place? Hundredths. Both of those are the same. All right, I know I'm throwing a lot back at you. Some of you guys are like, I know this shit. What are you doing? And some of you guys are like, slow the hell down. All right, so how do you change from a mixed number into an improper fraction? 100 times 1 plus 12, 112. Bam, there you go. All right. So either one of those is good. Is this coming back? All right. And again, something I say a lot is if I'm going too fast, slow me down. If I'm going too slow, deal with it. Right? Because we're not all on the same page with some of this stuff. Yes? What about number 2? I didn't see as many answers for that one. How do you calculate a percent? What you got?
I said that since 5 out of 40 people in the room are left-handed, just make that a fraction.
And then you could do like you did on the first one, yeah.
Yeah.
Yeah. I think that's what you did too, right? Or how did you do it?
I did like a really long way. I found out 5 goes into 40 8 times, and then honestly, I have no idea what else I did to find that.
Neat. Well, all right, so both you did the same kind of thing. You just kind of went a little different ways after that. So, yes.
I did it as, 40 times 2.5 is 100. So it's just 5 times 2.5.
Yeah, so another way you could do it is, all right, so let me show all of this. I love it. That's basically what I would do. Where am I? Here. So it's one thing you gotta realize about percentages is it's always part divided by whole, right? People forget that's the basic definition of percent. It's the part that describes what you're looking for divided by the total. So when we get the probabilities, that's all they are. The number of things that match what you're looking for divided by the total number of things it could be. That's all probability is. So it's going to be 5 out of 40. So 5 out of 40. That reduces to 1/8. I think this is what you did. So you could divide 8 into 1 and do it this way, right? You with me? Okay, so if you do it this way, 1, 8, then do 2, 0, 2, 16, 4, 0, 5. So you finally get 12.5%. So it's 0.125, so 12.5%. Is that cool? So basically, the definition of how to get a percent of something is you put part out of whole. Okay. Very often I'll have somebody tell me the answer is 8% because they did 40 divided by 5, but that doesn't make any sense. You wouldn't say 40 out of 5 people liked it. You're like, who the hell, what? You just making 35 people show, what the hell? Okay. Here's a really cool way to do this. You all know what 1/4 is, right? What's 1/4 as a percentage? 25%. Isn't 1/8 half of that? So what's half of 25? 12.5%. That's the way I would do it. And the way you did it is kind of cool. You said, okay, 5 out of 40. Let me kind of adjust what you did, right? Watch this. If I divide the top and bottom by 2, don't I get here? And then if I multiply by 5, I get basically this, which is 12.5%. So there's like 3 different ways there. This is roughly what you did, in a different kind of way, yeah. You guys all, okay? All right. By the way, just to remind you guys, the minute I go over this, I don't assume that you're able to do this out of nowhere, right? This is just trying to dredge up some memories, just trying to get you back in the math frame. All right, this one, anybody freaked out about this one? Like, what the shit? are those? So it almost doesn't matter what those are. They're just freaking symbols. So all variables are placeholders. We just happen to use our alphabet. We could use the Greek alphabet is the next thing that math people like to use, right? But we could use freaking little happy face. We could use whatever the shit we want to put there. There's symbols to stand in place of numbers we don't know. Is that cool? So one of the most prevalent algebraic idea that shows up in statistics is just variable manipulation, solving for some other variable. What sucks about this, besides the Greek letters? Let go of the Greek letters, right? What really sucks the most about this, trying to solve for a letter? Does anyone know? What do you wish wasn't there besides the whole problem? Let me answer the question. Wouldn't it be better if that wasn't there? How would you solve for x then? Add mu. Add the little weird u with extra legs. So this is called the Greek letter mu. I call it the French cal. Mu. Of course, that's a good example of my silly freaking sense of humor. And then this is the fat R. This is officially called sigma. This is lowercase sigma. You guys with me? Maybe. All right. So I want you to realize when I teach algebra, I try to get students to understand what part of the equation do you not like? Can you do something about it? The beautiful thing about equations is I can just do something to both sides. If I wish this wasn't there, I can make it not be there. I can kill it, right? How do I kill it? Right now it's being divided by this fat R dude. Multiply by the fat R dude, right? Or sigma. I should probably use the real. So if I take this and I multiply by sigma, both sides, to make it legal, there, it's not there anymore. Let me write this like this. And I can do what you guys told me to do the last step, how to get x by itself. Add the little weird mu dude. So we get x equals mu plus z sigma. This is an actual formula we're going to see later this semester. And so is the first one. So these are both the same formula, just written in a different form. Okay, maybe. I can see you guys second guessing your life choices, but you'll be all right. You'll be all right. Number 4's got one extra thing on top of it, right? What really sucks about number 4? Where's the variable I'm trying to solve for? Where is it?
Radical.
Under radical, which is itself under a whole fraction, right? You guys with me? That sucks so much. Here's stay with me. This is so cool. And of course, I know I'm the math teacher. I think all math is freaking cool. But watch this. Watch this shit. What's 10 divided by 2? This is amazing. What's 10 divided by 2? 5. What's 10 divided by 5?
2.
Didn't these just switch places? Of course they did. 10 divided by one chunk is the other chunk. I don't care which chunk I do. Are you with me? What does that have to do with this problem? I don't know. Oh yeah. If this divided by this is this, I could switch these. Not 2, Jeff. Over E. These just switch. Let me do it step by step. So let me start over again. I'm going to show you how to get here the long way. You ready? So if I have E equals Z sigma over square root of n. Can I multiply both sides by square root of n? That's a lot like what we did with this sigma dude, right? All right, so we multiply both sides by square root of n. Die. So then I have square root of n times E equals Z sigma. Then can I divide by E? Doesn't that mean, see how these just change places? They just change places. And what's the last thing I do then? What do I have to get rid of still?
Square root.
Square root. What's the opposite of square root? Square. So then I get die. N equals Z sigma over E squared. Which again, is a formula we're going to see later this semester. And hopefully by that time we'll understand what the hell Z means, what the hell little fat R dude means, sigma, so forth. Okay. You guys, I keep checking in with you because you all have this more. And again, you don't have to understand this whole sheet right away. You're not gonna have to be able to do this yourself tomorrow. This is gonna come up through the semester. Okay. Number 5 is the one I'm really, not number 5, number 6. Number 5 should be pretty straightforward. I think you all should know what we colloquially mean when we say average. To be honest, the word average means something different in math, because average could mean either the average we think of, or it could mean a couple of other things, to be honest. So there's a word we use instead of average in statistics. We call it the mean, right? So in statistics, we're going to use the word mean, right? Because math people like four-letter words that start with M, right? But we use the word mean instead of average, because average in statistics is not specific enough. It can mean several different things. But in our everyday language, we know what that means. How do I find the average of any set of numbers? Add them all up. Divide by how many there are. I love it. So when you add all those up, you get 39. Is that right? 39.
39.
And then you divide by 5. And really quick, watch. Okay. A quick way to divide by 5 is sort of a trick we used earlier. If I multiply by 2, right? This is 7.8. Bam. Is that right? Okay. All right. And then finally, this is the one I'm really curious about. I'm curious how you guys did it. I saw the answer, and then somebody even asked me, here's the number. Do I have to show you how I got it? I'm like, yeah. So just to really make this clear, I'm going to say this a lot. I even have a shirt that says "Show your work." Your work is the most important thing. The answer is secondary. The answer, if you get the answer right, that's nice. That's icing. The work is what's important, right? So you have to show me what's going on. That's why if you're, you don't have to tell me this, but if you've taken statistics before, some of my colleagues use the calculator a lot more than I do. I will show you how to do stuff on the calculator, but we're going to do a lot more stuff by hand. And that probably make you go, I picked the wrong guy. But because to me, the more you do by hand, the more you connect with it. Instead of this little black box spitting a number out at you, it doesn't mean shit to you, right? Some of you guys are like, I'm cool with that, but it's too bad. I'm going to try to get you to connect with these formulas and what it means when you get that stuff out. So, who thinks they got number 6 right? A few of you guys. All right. So I know you two were 2 of the ones I saw with the answers on there. How'd you do it?
I know to find the average, I need to divide by 3 for the third answer.
All right, 11. So let me catch up real quick. If you have an average of 80 amongst 3 grades, right? That means you're going to get something divided by 3 is 80. Right? In fact, the sum divided by 3 is 80. Okay, keep going.
Yeah, and that's what I did. And then I just did 3 times 80.
Yes. So we don't have a clue. If I know that 3 numbers average to be 80, do we know anything about each individual number? I ain't got a clue. In fact, I can make 2 of them up completely. And then I can make the third one work to make the average something specific. But if I have 3 numbers that average to be 80, I know that they add up to be 240. They have to. Because how do you find the average? Add them up, divided by how many there? So add them up divided by 3 is 80 means you add up to 240. They have to add to 240. And you already got 2 of them, don't you? So these 2 add up to be how much? 153. You need it to add up to be 240. So how much are you missing?
87.
Subtract these, 87. Kick ass. No. Did anybody do it a different way? I think. No, okay. Let me show you. That's not the way I would do it. You ready? Let me show you the way I would do it. And you're all like, I don't care the way you do it, weird math person. Ready? Isn't this up 1 from 80? Don't I want there to be 80 at the end?
Yes.
Isn't that up 1 from 80? Isn't this down 8 from 80? Aren't I overall down 7 from 80? So I better make this one up 7 from 80. Done. Right? Now again, that's not going to come up a lot in this class, but it's just a way to show you there's multiple ways to think about problems. And that's why I want to see your work. Because you could get the wrong answer, but the way you thought about it was close, and you just made one little mistake or something. If you don't show me any work, I can't see where the disconnect was. I got to assume the worst, right? Okay. Maybe. All right. there's that. I am recording, by the way. I'm gonna put this up on, normally I get them up on YouTube that same day, so it should be up there this afternoon, the video. Okay, so what we're gonna do now is we're going to kind of reset. You guys can kind of go back to your areas. We're gonna do a little bit out of chapter 1, and then we're gonna head out a little bit early today. I believe, what time did we go till? Yeah, 10:50, okay. Whoa. All right, that'll work. All right. One thing that we did for those of you who were in the athletics cohort, they should have sent out some like definitions and such, but I don't know how much you've been able to work with those. So let me do this. I know how exciting definitions can be. I know how exciting a stats teacher can be, which is normally not very. But so I try to explain these definitions by thinking of an actual real life example. So does anybody, can you guys tell me, the Grossmont College community of students, right? Is there anything you would want to know about them? Like, the first thing that comes to my mind is the percentage of Grossmont students who smoke or something silly, right? Is there anything you guys can suggest that we could study if we could go talk to some people to figure something out? You know what I mean? Like their average age or something, right? Or does that sound all right? You want to deal with that or what? So, average age, okay. So we're curious about the average age. By the way, that's how I write. So if you wanted to be able to read what your teacher was writing, you chose poorly. Grossmont students. I got to get some new markers. That's what we want to know, right? And we're going to do a statistical study to figure out an approximation of the average age. This is what we do. This is stats. What would be our population in this problem? Population. All Grossmont students, all of it. So the population is the entire group you're trying to say something about. Right. Normally we don't work with the entire population because it's too freaking big. Yes? So in this case, our population will be all Grossmont students. Now, does anyone know how many Grossmont students there are?
5.
A little more. Thankfully, we're not down to 5,000. We'd be hurting big time. It used to be 20,000. I think now it's about 14. We got about 14,000 total Grossmont students. Do you guys want me to assign you a project where you have to talk to all 14,000? I'll do it. No, I'm not going to do it. No, you would. So, of course, what do we do in real life? When we have a whole population we're going to say something about, well, we don't have time or resources to talk to each one of them or look at each one of them. What do we do instead? We take a sample, right? Is that cool? So very often you'll take a sample of water to see the parts per million of something to see if it's causing cancer or something, or you'll take a sample of whatever just to get a feel, because you can't possibly test the entire lake or the entire ocean or the entire, you can't. So you take a sample. So can anybody come up with a possible way we could take a sample of Grossmont students? A subset of the population that is then actually studied. Yes, this is English. So it's a subset of the population that is then actually studied. And by the way, Nick, I'm taking a video, but you can take pictures too.
You have to like, randomly assign.
Okay.
people based
So-
on something that doesn't affect your outcome.
Okay, you jumped a little ahead, but that's cool, right? So one way would be to somehow assign every student a random number, and then pick them like out of a hat or something, right? Is there another way we could do it, maybe?
Pick random classes.
Okay, now be a little more specific. I like this, right? So the random number generator is kind of cool. Let me put that down. A random numbers assigned and picked, right? Okay. Sorry, go ahead.
Just random classes from each department.
Random classes from each department, and then what would you do?
As their age.
Oh, everybody in those classes.
Yeah.
Okay, gotcha. Each department, ask age. Would this be at a specific day or time or something? Or
Probably have to be a specific time because I had to be. a
all right.
specific time.
So if you're on like if our class is now and I say go, so you would go
I
to.
have to pick a class that's 9:30.
Okay,
Right.
all right, I'm with you. So let's say on Tuesday at 9:30. All right. Is there somebody have another way we could do it? I mean, it captures some of the essence of every way we could do it. Is there an issue with the? I love it, but there's an issue with the way you're doing it, right?
Yeah.
What's the issue with the second way?
If you don't have a class on Tuesday at 9 o'clock, you kind of subtract a lot of people.
Oh, subtract a lot of people. What do you mean?
Like
You're there.
you take away half of the students, like majority of the students are they don't have a 9 a.m. Like,
Got you. Okay, I got you. Yes.
I was gonna say it's not, it doesn't accurately kind of represent the whole population.
Yeah, because
not with the-
exactly because you have a whole. When you say subtract, here's what you're really kind of getting at. There's a whole group of people that could never be in your sample.
Yeah.
So, what do you guys think? If I want to get a sample from a population, I need it to represent the population. What's the best way we, as lowly humans who don't know shit, what's the best way we could try to let that happen? Is to make sure, here we go, oh shit. When I slow down, that's like a note. You make sure that every element or person in the population has an equal chance to show up in the sample. If there's somebody in your population that has no chance, like if there's a group of people that because of the way you picked, they can't even be in your sample, do you think that's representing your population? Shit, no. And what happens all the time? How do they do polls for elections? Very often they used to call landlines, and then everybody started migrating to cell phones. So for a while there, they weren't really representing the population of people that had cell phones. Now they call cell phones, but is it possible to get all the cell phone numbers? No, I mean, so there's still these things that they have to adjust for because they don't have a truly random sample. So you see how the word random shows up a lot. We kind of have an intuitive sense that's important. Right? You don't want to go, well, I'm going to pick everybody whose name starts with J, because mine does, and I like those people. No. And you can't go, well, I'm going to talk to all my friends, because I know them. No, there's bias in that, isn't there? If you talk to just people you know, there's a reason you know them. And it might sway the results of what you're asking, right? So random is huge. So in order to have a random sample is the most important thing. Here's the definition again. The gold standard, well, to be honest, it's a simple random sample, but I'm not going to talk about that yet. Gold standard, random sample. And this means, holy crap, Jeff. Let's try to get English in there. There we go. Random sample. Every member, let me say it like that, every member of the population has an equal chance to get into the sample. Good Lord, Jeff. Every member of the population has an equal chance to get into the sample. That's what you're always trying to do, whatever method you use to pick.
So could you do like a poll that, like email out a poll and make it available for 24 hours and whoever doesn't do it doesn't?
What about people that don't check their email all the time?
But I mean, if you have your email, if you're in the school, you have an email.
I know, but do they check it all the time?
That-
No, I'm not coming down on you, dude. It's
Yeah.
for people who are doing surveys and such, it's the problem, right? How do we get this in front of people, and how do we get them to return it? Because that becomes like a voluntary response sample. So you send out all these things, and only a certain percentage return them. If you asked, can you tell us if there's what you've liked or not liked about your experience, who do you think is going to give the most responses? The people that have problems, right? So very often you get this skewed, you're like, oh shit, we suck. Because the people that were okay with it aren't going to have anything specific to say, but the people who had a problem, they're going to be like, this and this and this. So very often on like call-in shows or whatever, you're going to get the people that are upset about something, right? And then people are going to get a wrong impression about what the real issues are. Okay, possibly. So we're always trying, no matter what method we use, we're always trying to make sure as much as we can that we're not eliminating people from even having a chance to be in our sample. That means it has the best chance to be representative. I love it. Now, did any of you, let me see, have any of you voted in any elections? Or are any of you looking forward to when you will be able? I don't know if everybody, probably not everybody in here is old enough to vote. Is that true? Anybody? You don't have to tell me, sorry. So, has anybody ever paid any attention to like polls about what's going to happen in an election, right? And you get all this different stuff about how much can you trust the poll and so forth, right? So every time you do a poll, you're trying to make it representative of the population, but they almost inherently can't be. There's always going to be something not quite right, and that's why they don't fully match what happens, right? And that's why, real quick, have you ever seen something that says 40% going to vote for this guy, 42% going to vote for this person, and at the bottom it says plus or minus 4%? Have you ever seen that? No. You're like, I don't look at that shit, Jeff. What are you talking about? I'm too busy. I understand. So we're going to actually learn this semester where that plus or minus 4% comes from mathematically. There's a place it comes from, right? And how do you think? So the plus or minus 4 means, 40%, we think 40%, but it could be 36 to 44. It could be between there. We don't know. Are you guys with me? That's what that means. How do you think you would improve that? Like 36 to 44. If somebody said, 36 to 44%, that's not terrible, but it's not great. So what's one thing you think they could do to make that become smaller, to make them more sure about what they're getting? Does that make sense about my question? Take a larger sample. That's the quickest way to try to reduce that size. So when we get to the point where we talk about the math behind the plus or minus whatever percent, the sample size is going to show up because it's a part of what controls how sure we are. So the larger the sample we take, aren't we going to be more certain about what we see? If I talk to 3 Grossmont students and they got an average age, how do you feel about that representing the average age of all Grossmont students? Do you think it's going to do a good job? Oh, hell no. Could we accidentally get the exact average age? But is that a high chance for that? No. So it's all about the chance that something happens. Okay. So we got, all right, so Jeff, good job. You got 3 definitions. All right. Population, sample, and then random sample is actually a form of sampling. And later we'll talk about all the different ways to sample. Okay, I try to warn you guys, this first chapter is definitions like crazy. All right. So in purple is obviously the specifics about the situation, in red is the definitions. So we want to know the average age. Our population is all Grossmont students. We're going to do this first one, right? So we talked about the issues here. How would we improve this one here? How could you make this one better?
You would have to like make it on any given day, any given time, and also include online people.
Yes, good, because this kind of eliminates online. If you're kind of physically walking around, we got a lot bigger online population. You'd have to randomize the classes and the times also, right? And that would get closer to the gold standard of random sample. Okay, I love it. I didn't have a problem with your suggestion, by the way. It's a beautiful idea. It's just, you gotta make a few more things more random. Okay, so there's those. Now, let me ask you this. I think the book does this in a different order. Oh, good. All right. Once we get our sample, in fact, even before we get our sample, it's the average age of all Grossmont students. That's the number we're trying to get. That's the numerical description we're trying to get. You guys would agree? That's what we decided we're trying to figure out. So there's a word, parameter. You see how it starts with a P? It's going to kick a lot of ass. Parameter is your numerical description of the population. So if I said the average age of all Grossmont students is 28.3 years, that is a parameter because it is describing a population, right? Thankfully I'm wearing a mask or something. Okay. So parameter is a numerical description of a population. So you would hope that the word that's a numerical description of a sample, you would hope it would start with the letter S, and it does. Kick ass. And it actually is the word. What do I mean by that? You'll see in a minute. Oh, shit. People at home, you can finally see all of what I'm writing. Okay. So, for example, let me write in purple. We could get, like if I said 29, the average age of all Grossmont students, G-House, Grossmont students is 29 point whatever I said. That would be a parameter because I'm describing the population. So what's the numerical description of a sample is called a statistic. It's crazy. There's an actual, there it is. That's the name. So numerical description of a sample. Now this is the one that we know for damn sure. If we go out and we do either one of these methods, the improved method or this method, and we get like 100 Grossmont students, and we get an average age from those 100 of 27. That is a statistic because it's describing the sample, yes? If I try to then say, well, from our study, it looks like the average age of all Grossmont students is 27. Is that necessarily true? No. And that's where the plus or minus stuff would come in. We'd say plus or minus 3 years or something, right? Depending on what the math came out with. Okay. So this could be out of 100 randomly selected Grossmont students. Oh my gosh. You don't dot and E, John. You got an average age of 27. That would be a statistic because it's describing the sample. Now, what do you guys think? Does 100 seem like a good sample size?
No.
It sounds like it wouldn't be. It's actually not that terrible, but it's not great either. But it actually would be okay. It's just our plus or minus would probably get bigger to cover our ass. It's kind of nice. The smaller your sample, the bigger the plus or minus number has to be to cover your ass for the things you don't know. Bigger sample, smaller plus or minus. Okay. Okay. And then, do I want to talk about that? Sure. Okay. All right. So we got like a story here. We got something we want to say about a population. We take a sample, we analyze the sample, get a statistic, and then we can infer something about the population. That would be the parameter. So we want the parameter, but the best we could do is get the statistic. Okay. I like it. Maybe. Okay. Erase all of this. You ready? Okay. we're gonna kind of drill down on a few things. What was that? 1, 2, 3, right? There's something called a variable.
This would be 5.
5, is that 4?
Yeah.
I can't count. Okay. I'm not good with numbers. Variable. Now, in algebra, the variable is normally a letter that could represent a lot of different numerical possibilities, right? In statistics, it's sort of like that. So what are we going to be asking the sample we take in our example?
How old are you?
How old are you? Is that crazy? That's probably the best way to get their age. If we don't trust them, let me see your ID. Right? Okay. That is the variable. The variable is directly related to the question you would ask the things in your sample, or that you would look for. You guys kind of with me? Now again, what's the homework going to look like for chapter 1? They're going to give you a situation, and then they ask you what's the variable. So what are you going to think? What was the question they asked the things in their sample? That's the variable. You with me? Okay, I love it. So variable is related to the question. And why does it make sense? Again, in algebra, a variable could have a lot of different outcomes, yes? If I ask somebody what your age is, can that question have a lot of different answers? Yes, so that's why we call it a variable. The question we ask, because there's a lot of different possible answers they could have. Related to the question we ask the sample. So in this case, it would be, the variable would be the age of a person in the sample. That would be our variable in this specific case. All of the answers to that question are collectively called the data. So the data is just all the answers that we actually get from that question. So here I'm 19, I'm 29, I'm 23, I'm 87, whatever. I think 87 was the oldest student I had. I like that guy. He got bit by an eel when he was scuba diving once, this 87-year-old dude. I'm like, I want to be doing that shit when I'm 87. Thank you very much. Anyway, sorry. Total side note. Sorry, all the answers to the question. So the variable is related to the question we're going to ask. So the variable for this would be the age of a person, because we're going to ask, what is your age? We're going to ask each person that, right? And the data is all the answers to that question. It's just a list of all the answers, right? If this was my data, it's a really small sample, but then how would I calculate the statistic? Take the average, right? Well, the statistic in this case would be the average age of the people in my sample. I like it. Maybe. Okay. The parameter, are we able to calculate the parameter? Hell no, because we don't have everybody in the population. We don't have all their ages. Okay, hold on. So let's break out a couple of things, and then I'll let us out early like I promised. I'm going to do 2 more things, and then we're going to head out. Let's look at data. Let's break that up. Let me put it under here. So data. You could have something called qualitative data, and you could have quantitative data. Quantitative, yes, okay, good. It's like banana. I don't know when to stop. Real quick, what's the root word of quantitative? Quantity, right? So quantitative data is truly numerical data. Normally it's like measurements or something, right? So quantitative data is truly numerical data. Numerical. Qualitative data, the root word is quality. So it's also known as categorical data. So for example, hair color would be qualitative data. It's not truly numerical. Whereas the amount of money you spent on your last haircut, that would be quantitative data. That's truly numerical. You guys with me? What about the number on your jersey? If you're on a sports team, your number, whatever, right? So if you're number 12, you're number 27, whatever, is that quantitative or qualitative?
Quantitative?
So is it really measuring something?
Oh, no.
Is 27, whoever's wearing 27 better or worse than the guy wearing 26? No, it doesn't mean shit. It's just another name, right? If I'm watching the game, I'd be like, oh, 27 just caught the ball. It's just like me saying Fred caught the ball, right? I didn't just say the guy who has a measurement of 27. What are you talking about? No. So that would actually be qualitative. I love it. What about Social Security number? Qualitative. I love it. It's just kind of like another name for you, right? Another way to identify you. You can categorize you. Okay. So this is also called categorical data. It's normally names, things that aren't really numerical. All right. So the two Q's, qualitative, quantitative. Those are the two big ways to separate data. Okay, I like it. And here's the last thing. I promised you we're only going to do two more things. Here's the last thing. There are 4 parts to it, though. Ha ha ha. Just like a math teacher would. We could break this stuff down even further. And this time we're looking more at the variable, to be honest. So there's ways to categorize. Let's see, what do we call it? Levels of measurement, I think is what the book calls it. I always try to, every book is a little different. Just go with me for a bit. This is just kind of break this out a little bit more, just because. So on the most basic level is something called nominal. Most basic level. I don't know if any of you guys, some of you guys like to read some books. No, some of you guys are like, I wait for the movie, man. What are you talking about? For example, anybody ever read any Stephen King books? Stephen King?
Yeah.
Do you know Stephen King, when he started, he didn't call himself Stephen King. Did you know that? There are some Stephen King books you might never have read because you didn't even know it was him, and they're really good. So when he first started writing, he used what's called a plume de nom, a pen name. Nom means name. He called himself Richard Bachman. So if you like Stephen King, look for some Richard Bachman books. They're Stephen King when he was young. And there's some really freaking good ones. All right, sorry. So what all that shit was just to tell you, nom is name. Nominal is the most basic level of measurement. It's just your freaking name, right? So again, it could include social security numbers. It could include the name of like hair color. Anything is just the name. Stay with me. We're almost there. This first day, I know it's been nothing but exciting, and I'm sorry. Nominal. The next level is ordinal. It's still names, but it's got one extra thing. What do you think the root word of ordinal kind of relates to? Order. So, for example, if I was describing the order of how people came in a race, let's say you were the 7th person in, that would be ordinal, because that's the order that you came in. If I said, for example, when you go to a restaurant, anybody ever went to a restaurant where they had a little piece of paper? Maybe it's not the best restaurant because they have a little piece of paper and say, rate our service, excellent, good, fair, poor, whatever, right? That's ordinal data. If I ask you to rate my service and I put good, fair, excellent, poor, you're going to be like, what the shit are you doing? That's not in order. You guys see what I'm saying? Have any of you guys ever filled out faculty evaluations? So if you haven't, they go from strongly disagree to strongly agree. Yes? And you fill in the little bubble. What if it went disagree, strongly disagree, neutral? You'd be like, what the shit are you people trying to pull? Put that shit in order. So aren't they just names? Disagree, agree. Aren't they names of states of us? Yes? But isn't there an order that they need to come in to make sense? So they are names, but they're names that require a certain order. So be careful. If I started listing cars in the parking lot, types of cars, like I said, that's a Ford, that's a Chevy, are you going to go, wait, you should put Chevy first? Is there a reason Chevy should come before Ford? No. I could put them in alphabetical order. Do they have to be in alphabetical order to make sense? Nope. So be careful. Just because you can put them in order doesn't make them ordinal. There has to be some inherent order they need to be in to make sense. These two, let me put that, inherent order. We're almost there, guys. Inherent order. These two are roughly qualitative. And the next two are going to be quantitative. I like it. So 2 more and then we're done for the day. All right. So let me put these two at the same time. There's one called interval, and there's one called ratio. Yes? Okay. So when I say something like interval of time or something, can somebody give me an example of an interval of time?
Like 20 minutes ago was the interval time.
Oh, the interval time from 20 minutes ago to now.
Yeah.
So there's a beginning and an end.
Yeah.
So what can you do? Can't you figure out how long the interval of time is? So if I said it was from 5:01 to 5:17, how long was that interval of time? 60 minutes. So this is data that's numerical where subtraction makes sense. So if I subtracted, now this is funny, I got to tell you this story. So a while back I was teaching a class and I had like 3 people sitting up for, they were all on the women's basketball team. And I said, if you subtract Michelle's jersey number from Betty's jersey number, that doesn't mean anything. They're like, no, it's you get 14 minus 12 is 2, and that's Sherry. And I'm like, oh shit. So jersey numbers are not interval because when you subtract them, does it mean anything? No. Do you guys with me? So to be interval, subtraction has to actually make sense. So what if I subtract 2 zip codes? Do I get anything meaningful? No. Okay. So interval is data where subtraction makes sense. Ratio, what does ratio mean? Tell me in mathematics, a ratio is otherwise known as a, what's a ratio mean? Yeah, so it sets up a fraction, right? And what operation is related to a fraction? Division. So ratio is when division makes sense. So is anybody willing to tell me what year they were born? 2003. I was born in 1972. So if you divide, now as you subtract those two, 2003 minus 1972, do you get a number that makes sense? Does that number not mean anything? What does that number mean? 2003 minus 1972. That would mean how much older I am, yes? So that's what I mean by makes sense. It's got to make physical sense. Subtract 2 zip codes doesn't mean shit, yes? Subtract 2 years of birth, that means something. How much older the other person is, yes? If I divide those two, doesn't mean shit. No. I kind of gave it away with the way I asked that question, I'm sorry. But if I divide those two, it doesn't mean a damn thing. So, year of birth would be interval, but not ratio. Ratio is the highest level. It means you could do all the shit to it. So ratio means division makes sense. It also means that 0 means the absence of stuff. So, age. Is anybody in here 25? That would be awesome. No? Shoot. Is anybody here 20? You're 20 roughly? Okay. Almost. Let's say you're 20. So if you divide my age, 50, divided by 20, what do you get? Don't be saying damn. 50 divided by 20, you get 2.5, right? So it makes sense. I'm 2.5 times old as you. Roughly, right? And also age, what would it mean if I said somebody was 0 years old? They ain't been born yet. There's the absence of the presence of that person on the earth yet. They're not there yet. It's the absence of them. If I said I caught a fish that was 0 inches long, There's another way to say that I didn't catch fish. Yes? All right. The absence of fish, 0. What if I said it's 0 degrees outside? Is that the absence of heat?
It's absent of temperatures,
Can you get colder than 0?
yeah.
Yes. So Fahrenheit and Celsius, 0 does not mean what it's supposed to mean. So Fahrenheit and Celsius, interval. You guys with me? Does anyone know a third temperature scale besides Celsius and Fahrenheit?
Calvin?
Kelvin. Kelvin, 0 means we are all dead. 0 means what's called absolute 0, which means the absence of all energy. Yes? Holy shit. We don't want to be at absolute 0. So Kelvin would be ratio because 0 means what it's supposed to mean, the absence of that, whatever it's measuring. Oh my God, that was a lot. Okay. I apologize again. The beginning of our class, a lot of definitions. So just stick with me. We'll be okay. We'll get some meaty stuff next time. I think that's enough for today. Yeah, I'll let you out a little bit early. Yeah.
0 means what?
What it's supposed to mean. So, for example, real quick, profit. Profit for a company. What is, if I said the profit was 0, even though it could be negative, right? Can't profit be negative?
Yeah.
But does 0 mean the absence of that thing? Come on now.
You broke even.
Well, sure. So the profit, do they have any profit?
No.
The absence of profit. Therefore, profit is ratio. 0 is supposed to mean, what is 0 supposed to mean? The absence of the thing you're measuring. 0 degrees Fahrenheit, that's not the absence of heat. That's just some arbitrary place. Does that make sense? Maybe a little bit? But like 0 inches tall means that person ain't there, right? 0 words typed means you didn't even touch the typewriter. What the hell, right? The absence of words, the absence of something. That's enough for us. So come up and see me if you have any questions or if you need something. Yes?
Yeah, so for this,
We did, so today we roughly did 1-1 and parts of 1-2. So you should be able to do 1-1 homework.
Is that,
Oh no, that's for you guys. Yeah, thank you.
so wait, so we go on the website, and these like questions?
Yes, so if you're able to access the book, so you can either view the book online or you can download the PDF.
Yeah.
And then the problems are at the end of the chapter.
So section 1,
Can you wait for me?
1.23?
Yeah, you should definitely be able to do 1-1. You can try to do 1-2. I don't think we quite finished 1-2.
Oh no, I think you're gonna.
How you doing, man? It's been a while.
Hey, it's good to see you. Yeah, it was weird.